Hello. Today we're going to look at the ion product constant, Kw. Remember, K stands for constant, and in this case, W stands for water. We're looking at understanding three objectives today: 7.4.1, 7.4.2, and 7.4.3. The first objective is a definition, and it's defining what is the ion product constant for water. We need to know not just the sentence explaining it, but we need to write the expression, so the equation, and we need to know the value. So first of all, when we're looking at defining what the ion product constant is, this is the definition. It's the value of the equilibrium constant expression for the self-ionization of water. Now, what does that actually mean? Well, if you remember, water has an oxygen, which is quite big, bonded to two little hydrogens. And water is neutral, meaning it's got no charge. But what happens is that it breaks down. So we end up with an oxygen bonded to one hydrogen. We've broken down the bond, so this has a negative charge. And you also end up with a little hydrogen, and this has a positive charge. And what we're looking at is the relationship between the concentrations of the OH minus and the concentration of the H plus. So how do we write that? How do we look at it? Well, we're looking at what is the value of the concentration of the OH minus, and we multiply the concentration of the OH minus with the concentration of the H plus. And we're saying that water is generally a neutral substance, and if we've got pure water, then we can learn that at 25 degrees, Kw is going to be equal to 1.0 times 10 to the minus 14. And I'll show you how we calculate that number on the next slide. But for now, please remember, this is a value that you need to memorize. So let's think about this. Why is the value of Kw constant, no matter how much H plus or OH minus there is, or how they change? Well, let's have a think. So as you can see in this picture, when the value of H plus is a lot, we've only got a tiny amount of OH minus. And when we've got a large concentration of OH minus, we've got a tiny percent of H plus. But what you notice is that the height of the box is always constant. So what we're saying is that H plus and OH minus are inversely proportional. When H plus is big, OH minus is small. And when OH minus is big, H plus is small. And so you can see it written down. It's because increasing H plus decreases OH, because they're inversely proportional. And for your information, the concentration of the H plus ions and the OH minus ions for pure water, so that's when there's nothing else in it, it is only water, at 25 degrees, you can see the concentration is going to be 1.0 times 10 to the minus 7 for H plus, and 1 times 10 to the minus 7 for OH minus. If you can see, they're the same. And it's important they're the same because it's neutral. So these are the same. And if you remember that multiplying exponents is the same as adding them together. So 10 to the minus 7 multiplied by 10 to the minus 7 gives an answer of 10 to the minus 14. And this is a value that I've already said that you need to memorize. Now here is an example of a question. Calculate the concentration of H plus and OH minus using kW. So at 298 Kelvin, the H plus ion concentration in a cup of coffee is 1 times 10 to the minus 5 molar. What is the OH minus ion concentration in the coffee? Is the coffee acidic, basic, or neutral? So first of all, we analyse the problem. And one of the facts that we know is that kW is always going to be 1 times 10 to the minus 14 at the temperature of 298 Kelvin. The question is telling us that the H plus ion concentration is 1 times 10 to the minus 5. So we've got these two numbers. This one is from the question, and this one is a fact that we should memorize. And we're being asked, what is the OH minus concentration? The equation that we know linking kW with H plus and OH minus is that kW is equal to H plus multiplied by OH minus. So if we rearrange this, OH minus is equal to kW divided by H plus. So if we put the numbers in that we know, we end up with kW as 1 times 10 to the minus 14 divided by H plus, which is 1 times 10 to the 15. And in order to divide exponents, they have to be subtracted. So we have minus 14 minus 5, and a minus is a plus. So minus 14 plus 5 is equal to minus 9. And the original numbers, you divide them as normal. So 1 divided by 1 is equal to 1. So we're looking at this idea. So we can see that the OH concentration is 1 times 10 to the minus 9. And 1 times 10 to the minus 9 is smaller than 1 times 10 to the minus 5. So because the OH concentration is smaller, it means the amount of H plus is larger. And H plus will, a high concentration of H plus will mean that the solution, in this case the coffee, is acidic. If the concentration of OH was greater, then the solution would be basic. So how do we know if a solution is acidic, basic, or neutral? Well, I started talking about that on the last page. So at a neutral solution, you can see that the concentration of H plus and the concentration of OH minus is the same. They're both 10 to the minus 7. But on the left, we've got a greater concentration of hydrogen ions, and you can see that that means that H plus is going to be greater than 10 to the minus 7. Also, if you're looking at the acidic solution, that also means, if we look underneath, that the concentration of OH minus is going to be less than 10 to the minus 7. Because although 10 to the minus 10, 10 is a bigger number than 7, but remember they're minuses. So a minus 10 is actually a smaller number than a minus 7. And when we're looking at a basic solution, in the basic solution you can see that there's far more blue. The concentration of the hydroxide, the OH minus ion, is going to be greater. So here we've got OH minus is going to be greater than 10 to the minus 7. and the acid, the H plus, is going to be less than 10 to the minus 7. So neutral, we've got both H plus and OH minus are equal. In an acid, there is more H plus ions, and in a basic solution, there is more OH ions. So let's look at a practice question. This question is telling us that the H plus concentration is 1 times 10 to the minus 13, which means the question is asking what is the concentration of OH minus. How are we going to work this out? Well, we know that H plus and OH minus are linked by the Kw equation. So Kw is equal to H plus multiplied by OH minus. Kw is a fact. Kw is always going to be the same number. So what we're going to look at is rearrange this equation and then substitute. So OH minus is going to be Kw over H plus. Kw, our constant, is 1 times 10 to the minus 14. H plus concentration in the question, 10 to the minus 13. What are we going to do? First of all, we'd look at the coefficients. 1 divided by 1 is going to be 1. Then we're going to look at the exponents. So minus 14 minus minus 13 really means minus 14 plus 13 is going to give you an answer of 1.0 times 10 to the minus 1. And don't forget your units are going to be molar. We need to state whether the solution is acidic, basic or neutral. So H plus is 1 times 10 to the minus 13, which is a very small number, whereas 1.0 times 10 to the minus 1 is quite a large number, which means the concentration of the OH minus is quite large. So this is going to be basic, because the concentration of OH minus is greater than the concentration of hydrogen ions.